Hi everyone and welcome back to in Economist. This lecture is a continuation of our lecture number 2 where we solved some numerical questions of set theory. Now we will continue with the question answer session only in this particular lecture. Let's do question number 6. It says how many elements will be there in the power set of A if A is a null element, right? Now if A is 5, then first we need to determine what will be the cardinality of A. It will be 0, right? 5 represents the empty set, so cardinality of A will be 0. Now if you remember, we have given a formula regarding the number of elements of the power set. What was that formula? Number of elements in the power set or the cardinality of the power set will be simply 2 to the power the cardinality of set A. So it is 2 to the power 0, which is 1. So if a set is empty or it has only the element 5, it means the cardinality of its power set will be 1. Let's move to question number 7. If set A has 2 elements AB and set B has 3 elements ABC, is A is a proper subset of B? If you know the definition of proper subset, you will know that if A has all the elements that are also part of B and B has some extra element, here it is C, which is not in A, then A will be proper subset of B. This statement is true. Now what is A union B? If you write A union B, you will see it will be A, B, C, which is exactly B. So what is A union B? A union B will be exactly equals to B. This question can be formulated in another way, that if A and B are two sets such that A is a proper subset of B, then what will be A union B? A union B will be simply B, right? Next question. Question number 8 says find the union of each of the following pairs of sets. Number 1, A, where X is the natural numbers and multiple of 3. So it is 3, 6, 9, 12, so on and so forth. This is set A. And set B is the natural numbers less than 6. So it will be 1, 2, 3, 4, 5. Now let's take the union of these two. A union B will be what? 1, 2, 3, 4, 5, 6, 9, 12, so on and so forth. It will be an infinite set. So here you see set A has infinite elements but set B has finite elements. If you take the union of these two, the union set will have infinite elements. This is done. Question number 2. A is 1, 2, 3 and B is 5. So what will happen if you take A union B? It will simply be 1, 2 and 3. It will be set A. Question number 3. A is A, E, I, O, U, set of all vowels, and B is A, B, C. So what will be A union B? A, B, C, E, I, O, U. Let's move to question number 9. X is given as A, B, C, D. Y is given as F, B, D, G. We need to find X minus Y minus X, and X intersection Y. So let's start by finding out X minus Y. So all the elements which are in X but not in Y. So if you look at this set, you will find that there are two common elements B, D. Here also you have B, D. So if you subtract Y from X, this B and D element will go out and you will only get A and C, right? Question number 2 is Y minus X. Now let's erase this. Okay. Again, if you subtract X from Y, this B and D element will go away and you will be left with F and G. Question number 3. X intersection Y. X and Y has two common elements, which is B and D. This question is done. Question number 10. U is given. This is the universal set. A is given, B is given, C is given. You need to find A complement. A complement is basically U minus A. So eliminate 1, 2, 3, 4 from this universal set. You will have 5, 6, 7, 8, 9. Question number 2. You need to find B complement. Again do the same thing. U minus B. It will be 1, 3, 5, 7, 9. Question number 3. These two are done. A union C complement. First find out A union C. What will that be? 1, 2, 3, 4, 5, 6. And then take the complement of this. What will that be? 7, 8, 9. This is done. Then question number 4. It says A union B complement. Find out A union B first. It will be 1, 2, 3, 4, 6, 8. Then take the complement of that. It will be 5, 7, 9. Question number 5. A complement is nothing but A. So A is given as this. This will be the answer. Question number 6. B minus C complement. Find out B minus C first. So here you see 4 is there. And what else? 6 is there. So you are left with 2 and 8, right? And then take the complement of this. It will be 1, 3, 4, 5, 6, 7, 9. Pretty simple. Question number 11. You are given with the universal set, set A and set B. You need to verify A union B complement is A complement intersection B complement, and A intersection B complement is A complement union B complement. So if you can identify, this is nothing but the De Morgan's law that we have proved earlier. So let's verify De Morgan's law numerically now. Find out A union B. That will be 2, 3, 4, 5, 6, 7, 8. Then find the complement. That will be what? 1, 9. Now start with this side. Find out A complement. That will be 1, 3, 5, 7, 9. Find out B complement. That will be 1, 4, 6, 8, 9. And then take the intersection of these two. That will be what? That will be 1 and 9. 1 and 9, right? So what do we get? We got A union B complement is 1, 9, and A complement intersection B complement is also 1, 9. So these two are equal and the first statement is verified. Now let's go to the second one. Find out A intersection B. A intersection B has 2, and what else? Nothing else. So it is only 2. Take the complement. It will be 1, 3, 4, 5, 6, 7, 8, 9. Then find A complement and B complement, which we have already found here, and take the union of these two. 1, 3, 4, 5, 6, 7, 8, 9. So again, what you see here, you have A intersection B complement, and here you have A complement union B complement, and they both are exactly equal, so second statement is also verified. Let's do question number 12. It says that draw appropriate Venn diagram for each of the following: A union B complement and A complement intersection B complement. We just proved that these two has to be equal by the De Morgan's law. So let's verify this. This rectangle is the universal set. Suppose this is set A and this is set B. Similarly here we have the same thing, right? So A union B is what? This entire portion is A union B, and if you take complement, it will be the rest of the portion. So it will be something like this. You have to take into consideration everything except the two circles. It will be something like this. Everything except the two circles will be A union B complement. Now if you see this, it will be the same thing, but just to verify, A complement is everything except the set A, B complement is everything except the set B, and if you take intersection, it will be the same thing once again. So let me just do this. It will be everything except the two circles. Now let's go to 3. Universal set, set A, set B, set A, set B. A intersection B complement. A intersection B is this middle part, the common elements between the two sets. So everything except the common elements will be included. Everything except the common elements will be included. And again, these two are equal by the De Morgan's law. A complement union B complement. You can verify this from this diagram. This will also be the same. Everything except the common elements. Right? I hope this is clear. Let's do another question. It says, question number 30, fill in the blanks to make each of the following statement a true statement. What will be A union A complement? Suppose this is universal set and this is set A, so everything else will be set A complement. So if you take union of A and A complement, it will be entire universal set. You can verify from this diagram. Second statement says phi complement intersection A. Phi complement is nothing but the universal set. If you take complement of the null set, it will be the universal set, and then you are taking the intersection of that with A. Then what will that be? If you take intersection of universal set and A, it will return to be A, right? It will be A. Question number 3, A intersection A complement. So there is nothing in common between A and A complement, so it will be phi. Then question number 4, it will be phi, right? Question number 4, universal set's complement is phi intersection A. What will that be? There is nothing in common, so it will be phi. Let's quickly do question number 14. In a committee of 50 people speak French, 20 speak Spanish, 10 speak both Spanish and French. How many speak at least one of these two languages? So let us solve this. So 50 people speak French, 20 people speak Spanish, and 10 people speak both. What we need to find? We need to find who are the people who speak at least one language. So we basically need to find this, F or S. We need to find people who speak either French or Spanish. So it is union. The formula is right. So let's do this. This will be 50 plus 20 minus 10. So it is 60, right? Let's do question number 15. In a group of 65 people, 40 like cricket. Draw this to be cricket. So cricket is liked by 40 people. 10 like both cricket and tennis. Both cricket and tennis is liked by 10 people. So this part is basically intersection C and T, which is 10. Then how many like tennis only and not cricket? So we need to find how many like tennis only and not cricket. Tennis and cricket complement. This is what we need to find. And there are altogether 65 people. So we can say that C or T is 65. So in the diagram, I want you to identify the region which will represent this N number of people who like only tennis but not cricket. If you see carefully, this will be this region. This region particularly denote T and C complement, right? People who like only tennis and not cricket. So from the diagram, you can write this as NT minus N of C and T. You take everything of tennis and you eliminate this particular intersection region, then you will get this particular region. So first we need to find NT and then we need to subtract 10 from here. Now how will we find NT? We'll find from this expression. NC union T, basically NC plus NT minus N of C and T. NC is 40, NT is what we need to find. This is 10 and this union is given to be 65. So how will we get NT? It will be 65 minus 40 plus 10. Then how much this will be? This will be 25 plus 10 is 35, right? So there are 35 people who like only tennis. So we got this value, put 35 here minus the intersection which is 10, this is 25. So we got both our answers, that how many people like tennis and not cricket, this will be 25, and how many like only tennis, this is 35. Let us do one more question. Question number 16. In a survey of 60 people, it was found that 25 people read newspaper Age. Newspaper Age is read by 25 people. 26 read newspaper T. Newspaper T is read by 26 people. 26 read newspaper I. I is 26 again. 9 read both Age and I. Both Age and I is read by 9. 11 read both H and T. H and T is read by 11 people. 8 read both T and I. T and I is read by 8 people. 3 read all 3 newspapers. Number of people T, H and I is 3, right? Then we are to find the number of people who read at least one of the newspapers. At least one of the newspapers. So let's see how to do this. At least one of the newspaper means T or H or I, right? This will be NT plus NH plus NI minus NT and H minus NH and I minus NT and I plus N of T and H and I. Now just put in the values. We know every value. Just put in here and you will get the answer to be 52. Please verify this. You just have to substitute these values and the answer will come out to be 52. And this problem I want to give you as homework. Please think of it a little bit. It says that the number of people who read exactly one newspaper. You can solve it easily, and I want you to comment me down below in the comment section what is the answer of this question. This is a homework for you. And this will be our final question from this chapter. Let's do this. In a survey, it was found that 21 people like product A. So 21 people like product A, 26 people like product B, 26 people like product B, and 29 people like product C. In C is 29. 14 people like products A and B. In A and B is 14. 12 people like product C and A. What? It is 12, right? 12 people like products C and A, and 14 people like products B and C. And 8 like all three products. So A intersection B is C is what? 8, right? 8 people like all three products. Then we need to find how many liked product C only. Now you can find it with the help of formula as well, but there is a simpler way to do this. You can just put in values here in the Venn diagram and check what will be the answer. That will be a much simpler way. So let's see first what are the information that we already know and what is it we need to find. We need to find how many people like product C only. So in the Venn diagram, what will that region be? It is this particular region. These are the people, so this particular region, these are the people who like only product C. So if we can subtract this part and this part from this entire NC, then we will get our required region, right? So we need to find what is this value, what is this value, and what is this value. So let us do that. Okay. So it says that A intersection B is 14 and A intersection C is 12. B intersection C is 14. So we can say this will be 6, this will be 8, this will be A intersection B, which is 14. This will be what? This will be then 4. 8 plus 12, 8 plus 4 is 12, and this will be 6 again, right? And NC is given us to be 29. So the entire NC is given to be 29. Okay, so in A is 21, and here what you have 6 plus 8, 14 plus 4 is 18. So this will be 3. And in B is given to be 26, and here what you have 6 plus 6, 12 plus 8 is 20. So this will be 6, right? In B is 26, so this is 6. And then find out what will be this part. So this part will be total NC is 29 minus add the intersection portions. So this is 29 minus how much is this? 12 plus that is 18 and this will be 11. So our required answer is 11. How many people like product C only? So 11 people like product C only. So that's it for this video. I have some additional homeworks for you. You can take a screenshot of this and can think of this in your free time. And if you like this video, you can give us a thumbs up and consider subscribing to our channel, and stay tuned for the next lecture. Thank you so much for your time.